So I'm going to do a little bit more of a thorough explanation of the sign analysis for this function. I'm not in this video going to explain how I know that this function does in fact factor to this function, nor will I explain where these zeros came from. If you have questions about that, come in and see me. But once we have these zeros marked on the number line, we're just going to go through and use this factored form to figure out where it's positive and where it's negative. In class, I kind of started off with the one that's easiest to explain, but in this case, I'm just going to go from left to right, right? So I'm going to just start with the leftmost region and go to the rightmost region. So my first question is, how can I figure out what's happening from negative infinity up to this point? Is this derivative going to be positive or negative? And I'm going to look at that factored form. And since we're going from negative infinity all the way up to this value that's around negative 2.4, I'm just going to think about a really gigantic negative number, like negative 10 bazillion, whatever it is. And the basic idea is, in this factored form, if x is super duper 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 negative and I subtract 3, then really, really, really negative minus 3 is still going to be a negative number. And then it'll be multiplied by whatever this ends up being. And just like we did earlier in the year, if x is gigantically negative and it's some kind of polynomial function, this really does take over the entire function. These other parts are negligible. And so really gigantically negative number multiplied by itself is positive. So this factor will produce a positive result. And so I'll have a negative times a positive, which ultimately will be negative. So this entire region will end up being some kind of negative value. Now in the next region, it's going from negative 1 minus root 2 to negative 1 plus root 2. I could pick any number from this region. The decimal approximations were helpful here because it shows me that 0 is definitely between these two numbers. And I'll look at this factor with x equal to 0 and this factor. If x is 0 and I subtract 3, that'll give me a negative value. And if x is 0 and I square it, that's 0 plus 2 times 0 is 0 minus 1, so it becomes 0 plus 0 minus 1. It's negative as well. So I'd have a negative times a negative, which ultimately, like this is negative, this is also negative, negative times a negative is positive. So ultimately, this middle portion becomes positive. Hello. In this little region here, I actually have to pick a number to plug it in. I can't use any weird tricks. It's helpful to know that this decimal approximation is 0.414. So any number between 0.414 and 3 will work. Let's go ahead and use positive 1. If I have 1 and subtract 3, 1 minus 3 is a negative answer. If I plug in 1 here, it's 1 plus 2 is positive 3 minus 1. I need to write this part out, right? Because my brain's not that strong anymore. So if I plug in a 1 here, 1 squared is 1, 2 times 1 is 2, subtract 1. I can look at that and be like, okay, that'll end up being a positive answer. So a negative times a positive is negative, so this whole region, I'm going to mark that as being negative. And then finally, for the last region that goes from 3 all the way off to infinity, I'm just going to imagine a gigantically positive number, again, and not worry too much about the details. So gigantically positive, and I take 3 away, is positive. Gigantically positive plugged into here means these end up being negligible. Gigantically positive squared is still positive. So this is also positive. And so ultimately, that last region is going to be whatever positive times positive is. Positive times positive is positive. That's positive. And that's how I know that the derivative function is negative for negative infinity up to negative 1 minus root 2. And the derivative function is negative from negative 1 plus root 2 up to 3. So I could say f is decreasing on these intervals. I wish I'd made all that orange. You nerd. And then I could say that f prime is clearly positive from negative 1 minus root 2 up to negative 1 plus root 2, and f prime is positive from 3 to infinity, so I could say f is increasing on that interval. All right, that's 5 minutes of your life you'll never get back unless you watch this on double time, and it's just 2.5 minutes. If you guys have questions, let me know. Be safe.